the microphone, or it's okay?
You can talk freely, maybe just loud enough so people hear, otherwise we can always switch to mic.
Okay. I hope you can hear me. I should have a loud voice, so. Yes. Yes? Okay.
If you don't hear, just raise your hand and you'll know. I'll leave it.
Thank you. So I will do a brief presentation on two main topics. The first one will be about marketing values versus real-life performance and security values of different devices. And the second topic will be a bit about network visualization and how to reach certain points of the network in order to extract the information from monitoring and other reasons. So the first part of my presentation is about how to validate or how to verify that the device I'm going to use in my network is really doing what it's supposed to do, and to make sure it is not creating any bottleneck or any issue which is not expected or not supposed to do. The first slide I've put here is mainly about the information you get from a vendor brochure. I mean, when you go to any firewall vendor and ask them to deliver marketing information about their device, in their marketing brochure, the information that you will receive of the device performance is usually done under very, very vacuum, very clean conditions to show the best they can do. Unfortunately, they do it under a very limited and unrealistic condition just to show how powerful the device is. And because there is no real market standard, how you should publish your marketing values, each vendor can do whatever he likes to do in order to show that he's the most powerful, even so totally not realistic. One sample of how performance testing is done in order to provide numbers to the customer is by pushing HTTP traffic through a device and then measuring the performance. The HTTP traffic, which is usually used in the industry, looks similar to what I'm just displaying right now, which is a very, very empty, basic HTTP transaction which doesn't look like reality. In this response, you might be able to see that the response is a row of AAA or a single character, no spaces. Now, most security devices are using regex or fingerprinting to identify vulnerabilities and threats. Regex as a mechanism when there is no spaces and no real wording, very, very easy to accelerate and very, very easy to show high performance, even so totally, again, not realistic. A real network usually combines multiple domains, and for each domain, the security device will have different policies installed. Like another huge difference between the real numbers that you get in the implementation rather than the marketing values is in the QA lab, when looking to find the marketing values, they are turning off all the policies, so everything will be under any condition. They are turning the logging off, so the device doesn't log any information, so of course it's really easy. And then once you install, or once you take the device into the real configuration, then you have a real policy, real domains, full logging capabilities enabled, maybe IDS features and antivirus features, and all together now the performance will dramatically change. So like a real HTTP compared to the one previously displayed, a real HTTP transaction has tons of information to analyze. And if my next generation firewall is analyzing the content, then this will create huge performance impact compared to the one used in the QA process. Now, HTTP is just one protocol. So we are using the HTTP for the performance values, but in my implementation, or in my data center, I'm going to have Oracle application, SAP, Microsoft protocols like SLB, NFS, NTLM, a huge amount of protocols running in my network. So just having one protocol for my measurement doesn't really reflect the numbers that I will really have. And eventually the applications in my network works together. It's not just one application at a time. Everything goes together. Even worse, when I'm having a network attack, the attack will be part of my network traffic. I can't just evaluate the device how well it detects attacks only under attack condition without any normal traffic. Same as I can't evaluate the performance only using HTTP an unrealistic one. If I like to know how the device works under my condition, what a lot of military sector and government and enterprise customers are looking to do is under my protocols, under the attacks that I see in my network, what will be the reaction of the device. We are focusing on mainly basic 3 test cases. Of course, for validation you can be creative and find hundreds. But the basic one are performance. What is the real performance under my realistic environment? I mean, if I have 1,000 employees, I don't care this device can reach 60,000 connections per second. I care that under 1,000 connections, it can run my application correctly. Because maybe it can do 60,000 connections per second for HTTP, which is very nice, but I don't have only HTTP. I have other applications to analyze, but less customers. So what will I get? Security. I mean, there are DDoS, botnets, malware, viruses, whatever. How can I combine some attacks through the device with background traffic to validate it and really detect it and stop it as I'm expecting it to do? How well it is doing it? And the last one is stability. I'm not going to buy any next generation firewall. I don't care how sophisticated it is if it's going to crash every 2 days. I mean, my goal is not to go to the data center and reboot my devices every few days. So that's are the minimum parameters to make sure that if I am entering a large project and I need to select the next device to use, then this is a simple metrics of information I can gather before implementing the device to know I'm making the right choice. Now, it is very, very similar not only to firewall and IDS and WAF, but also for load balancing, denial of service devices, lawful interception devices. All the application-aware network devices are kind of having the same bottleneck and common problems. This is like real-life information from an event we have done in Italy for a very large, a very big customer. We took 4 IDS, IPS, and firewall vendors and ran some test cases to compare all of them. And the test cases were we were running both the marketing style test cases to validate that we can reach the marketing values which the vendor displayed. And then we were running real application protocol mix, so we see under the customer protocols what we will actually get from the same device. As you can see for connection rate, how many connections per second I can run through a device. If I'm doing pure TCP, TCP means there is no application running on top, I'm just opening and closing connections through the device. Then you can see the result, all of these devices were 10 gig devices. It was actually shocking to see the difference, the distance between what it's capable to do on pure TCP, and once there is application data running, and then it actually needs to analyze the data. So without any data, I don't need to analyze. If I don't need to analyze, all the processing done for application level are not operational, and the distance between only TCP and application was huge. So evaluating a device just by its TCP power kind of really misleading of what I'm going to get. We did the same for the bandwidth. So even on the bandwidth, you can see like in some cases approximately 50%. But again, if I need to send all that content into my CPU to analyze and open up the content and check what's going on inside to identify threats and attacks, then it takes tons of CPU power compared to no information at all. So in the first place, only TCP, it's more like working as a router. Maybe I do need to track the TCP behavior, but still, it's a very simple task comparing to opening up and gathering the information. We have done the same test using HTTP because still most vendors in the market will use HTTP for the performance values, because they like to show you that their marketing values are not just pure TCP but with an actual content. Still, even under these conditions, so now the connection rate looks a little bit more reasonable, like 50% below what they have claimed compared to the previous one, but still there is a huge difference. Now, I know that these numbers look like strange because there's no way the vendor will say I can do 100 while you can only do 30. Unfortunately, this is this was from a real event, from a real customer and a real device, and the protocols were selected by the customer itself. He told us today in my network I have A, B, C, D protocol. This is the percentage of each protocol compared to the others, and we just mimic his content to see what will happen. Same goes to the bandwidth. I mean, if you look at vendor number 1, it's a 10 gig device. Under the customer conditions, it could barely do 600 megs. So if I need to go to the purchasing department and justify this vendor, then I will justify it as a 1 gig device and not a 10 gig device. So this information is mainly used during POC or software upgrades to justify the step I'm going to do, because every step costs money. And now I can make sure I'm paying the right amount of money for what I'm actually getting. The last one we have done was a security test. You can see at the upper side how many attacks been detected by the device. When we were only sending attacks, there was no background noise of any kind. And once adding the background application, like a normal network application, we saw that some vendors had huge degradation in what they could detect with or without background noise. So actually my network traffic might affect some devices on their ability to continue and detect attacks. Like the last one, even though he was the best one detecting attacks, once I was starting to pump information in the background, he was actually managing to capture less attacks than vendor number 2. So vendor number 2 seems the most stable, because with or without attack, it could still handle its mechanism. So in total, our message out of this presentation is how can I verify that I'm buying the best solution to my network, and how I am eliminating the maximum uncertainty so I can select a device that I know in advance it's having the right performance, not creating the bottleneck, it is capable of detecting and protecting my network, and it is stable enough in 99% of the cases so I can, be confident that at 5 o'clock tonight I'll go home and not stay to reboot it. And that's, any questions so far? That's the first topic. The second topic I would like to talk in brief. I have like another 5 minutes. In any network, I have today plenty of tools to monitor for security reasons and other reasons, which are connected to certain points of my network all the time, using span ports like mirroring ports or taps and other solutions. The biggest problem with all of these devices is that whenever I'm doing a span port, all the information from this port will flow to the device, to the monitoring device, without any ability to change the link speed, filter out specific application, which only this one I wish to monitor right now, and so on. The monitoring visibility market, it's mainly coming to solve several solutions between my network and all the tools I have in my environment. The visibility solution is not replacing the monitoring tool, it's just allowing or enabling to deliver only the relevant information to each tool in a more efficient and easy way. The idea of the visibility tools is to make sure that each monitoring or each tool will receive only the information it needs to receive from the network down here, while keeping low performance. Like if I have a SIG monitoring tool that is tracking the quality of service of my SIG RTP or whatever. So if I'm tracking a certain point of my network and I'm having like 10 gig of traffic on this specific point, but usually SIG will not be more than 1 to 2% out of 10 gig. So my visibility tool can filter out only the SIG traffic from this point to the SIG monitoring tool, so the monitoring tool can focus only on the SIG information, and therefore it will not overutilize itself by trying to filter out on its own. So what this tool is usually doing is doing, first of all, aggregation. I can take information from multiple points of the network and aggregate it into a single point in my monitoring environment. Like if I like to compare a transaction, like a stock exchange transaction, which is very critical information, I like to make sure that there is no packet loss in my network and the latency of my network is minimal. So I can take, I can copy the information from one point of the network and then copy it again on another point. I can put a timestamp on both ends, and then I can compare the information to see that my network has no packet loss and that the latency measurement from side to side is perfect. But I'm not the one who will deliver the final information. I'm only adding the information to the data, so the monitoring tool will be capable of delivering the information that you need to monitor your environment. So again, the main focus of this product is to enable an easy access to information in the network by converting links from 10 gig to 1 gig if needed, to filter only the relevant information. I can actually move the information into a certain VLAN, so it will be easy to monitor a remote site and take the information back to my area and so on. So this is the next, second topic I wanted to cover in brief. I finished my information I wanted to share. If there are any questions, I would be happy to answer. And anyway, our booth is just a few meters down the corridor, so we'll be happy to talk more. And thank you for listening.